Okay, so this meeting will be recorded, folks. Thank you so much for joining. Super excited to do this with you all. There's a link in the chat in case there's anybody who hasn't opened it. Please do so. We'll be using this throughout, and I'll share my screen, and you'll see this very same link on my screen. And it's still loading for me. It'll take a couple of seconds. And you should be seeing something like this on your desktops too. And the idea is that I'll walk you through everything that's there on this website, and you'll get an opportunity to run everything on your screens as well. And we'll go really slow and we'll try and kind of take it step by step. But before we begin, just like a quick tech check, can you see my screen? Can you hear my voice? Okay, great. And I want to also start the live transcript.
Yeah, I can turn that on, Anuj. Hold on just a sec.
Thank you.
Okay, should be going now. I think we've got, yep, looks like we've got live transcript. Okay.
There's a live transcript. You can see me, you can hear me. So hopefully everything is good. But if there's any issues, just stop me in the middle and I'm happy to kind of take a little detour. Okay, so welcome to Coding and Decoding, Introduction to Text Analytics for Humanists and Social Scientists. Who am I? I'm a grad student in the Rhetoric and Composition department in the teaching of English program in the Department of English. And I'm just generally somebody who was mired a lot in qualitative research. But then over the last few years, I started experimenting, took a class in statistics, then took a class in Python, and then just kind of learned about this whole new world of computational social science and digital humanities, which is really opening up our respective fields. So I've been training myself in it. And then I got selected as a digital scholarship and data science fellow through the University of Arizona Libraries, which is where my colleague Jeff is from. And he's been super supportive. The library folks have been supporting many students like me to develop workshops like this over the last year. And my workshop will be about text mining. What we want to do in this workshop, one, we kind of want to explore some studies in humanities and social sciences that have used text mining techniques. We want to also practice some computational methods that can help in analyzing textual data. And the specific techniques that I want to talk about today, some of them are clubbed under this larger category of distant reading, which includes many things, but very basic stuff would be reading the frequency of words or plotting the frequency of words across a text, which is called a dispersion plot. We'll also try and do some close reading of texts through techniques like collocations and concordances. And if this is the first time that you're hearing these words, that's absolutely fine. You're not expected to know any of this beforehand. All this, everything that I'm giving in the workshop, this website, this recording, everything will be available to you after the workshop for open access, in fact, for everyone. So no need to take notes. This is like your copy. You'll be working on this. And finally, I'd also like us towards the end to brainstorm how some of these techniques could be applied to your own work. And before we begin, just wanted to everyone, let's take a deep breath. Learning coding using these new methods requires a lot of patience and compassion. I know that when I began, I used to be super anxious that, oh my God, there's all this complicated code and these numbers, and I think I'm not smart enough to understand them. And I learned it the hard way, but whoever I try and teach this to, I want to tell you that there's no right way to do it. It requires a long time, but we have to kind of scaffold our practice and really take baby steps. So my goal is to help reduce some of this coding anxiety that many of us feel. Errors are super duper helpful. The more errors you make while you're coding, the better it will be. And this workshop is not expecting you to suddenly learn how to become a coder, right? By the end of it, what I'm really expecting is that you learn a little bit about how code works, what's like its syntax, what is its grammar, and then how that can be utilized to analyze textual data. It could be anything. If you're a social scientist, it could be survey data, it could be interview transcripts, it could be Twitter data. If you're a historian, it could be archives, it could be literary text, anything that has words essentially. And it's really vital to have an exploratory spirit as we go into kind of these techniques. As I was telling, I'm an advanced novice. My journey is hopefully meant to inspire others. And in terms of logistics, we've already covered this. We have 2 hours with us, so we'll work together for the first 50 minutes and then take a 10-minute break and then kind of come back for a final 50-minute session and a 10-minute QA at the end. Right. Okay. Enough talking. Let's get started. What is text mining? I think I define text mining in terms of three kind of things. For me, it's like a mixture of a microscope and a telescope, specifically for the humanities and the social sciences. Like, usually we just use our naked eye and kind of brains to analyze and understand text, right? So, what these things are doing, I don't think that text mining is like how we usually imagine artificial intelligence, that there's a new entity which is going to kind of completely take away human agency and find these amazing results. No, it's just another tool which will help us see patterns in data that we haven't before. So it's really like a new organ that we're adding to our hermeneutic interpretive abilities, which allows us to see data at much larger scales, and it allows us to find patterns that are way more fine tuned. That's pretty much what I think it is. And now we can jump straight into the basic setup. This website that you see, it's something called Jupyter Notebook, which you can think of as like a Google Docs for coding. I hope many of you have already used Google Docs, but Google Docs is, if you haven't, it's like a Microsoft Word tool where you have a document you're writing and other people can collaborate and jump on it. So it's kind of like that for coding. So I just created this and I can share it with all of you. And let's try and familiarize ourselves with what this Jupyter Notebook is. What you'll see at the top of your screens is a menu bar, something like this. There might be slight variations based on the browser that you're using, but there's going to be a whole bunch of buttons there. We don't need to worry about all the buttons. The only thing you need to know about is the run button. This kind of triangle that you see just below the words run. When you click on it, it runs a code, as simple as that. So what you'll see below is certain cells which look slightly different in color. They have a rectangle framing around it, and towards their left, there are these two kind of square brackets. This is a coding cell. What that means is that this is a special cell where you can write code and then you can run it. So I've written a code line here which says print, hi, try to print me. And if you place your cursor on this block, and if you click the run button at the top, the computer runs this code and it does something. It gives a little output. And here the code was pretty basic, right? It was simply saying, take this sentence and just display it. So here at the bottom of this cell, you will see that this output has appeared, right? So I just like you to do this on your screens. Click on this cell and click on run. So you understand this very basic interface of how a Jupyter Notebook works. And once you've done it, just give me a thumbs up, please, so I know how many people have done it. Or you can type in the chat that it worked for them or it didn't work. Woohoo, congratulations, we've all done our first code. So you guys are officially coders now. We can start applying for jobs to Microsoft and Google and everything. But yeah, this is essentially how things work, that we write coding statements and we give it to the computer processes it, and then it gives us an output. So keep this kind of simple interface in mind. We are inputting something to the computer is processing it, and it's spitting out an output. Right. And here in Jupyter Notebook, what you see is when you run it, towards the left in the square brackets, you see a little asterisk sign for a brief moment. That essentially means that the computer is processing it. And when the asterisk sign changes to a number, that means that it's done processing. And it's a pretty simple code, so the computer barely takes any time. But if your code is a little complicated, it takes longer to process. Okay, so this was just the simple thing. Now, a little bit about errors. Now, the computer is, unlike humans, it can't understand flexible language, right? If I suddenly start to speak in language where the grammar is not quote unquote correct, if I start to say, he is blue ball plant die whatever, you'll probably think that I've gone insane, but you'll understand that okay, there are some meanings here. There's blue ball, green plant, whatever things, there's something going on. But the computer will not be able to make that inference if you don't use the exact kind of specific grammar or syntax or kind of language that it understands. So just like the code above said print, I tried to print me. Now you see here, I've intentionally put in a little spelling mistake. Instead of print, I've written drint. And then when I try to run this cell, we get an error. What does the error say? The computer has tried to process it, and the computer says the name drint is not defined. What that means is that the computer is telling us that while I understand commands like print, I don't have the word drint in my dictionary, so I don't know what to do with this, right? So what that tells us is that Python has a specific vocabulary and a specific syntax using which we can make the computer do lots of things. And if we break that syntax or we break that lexicon, then Python will simply tell us that there's been an error. I don't understand what's going on. Before I move forward, just want to take a little pulse check. Is everybody able to follow along? Are you getting the basic functionality? Is the kind of workshop working for you? Okay, great. Let's move ahead then. Right. So let's try and understand what Python is and how it works. Python has become really famous because it's very easy to use compared to many of the other languages. Lots of help is available online. You can easily copy paste other people's code and customize it for your research. And it's the closest to the English language and requires less jargon than other languages. So now let's try and build up a little bit more complexity. Right now, we just use the print function to print a command. Now let's try and do some mathematical functions. You'll see this code here on your screens. You'll also see it in your kind of notebook. Now, what does this code do? First, it says first number equal to 5. What we are doing here is that we are creating a variable called first number, and then we are saving the number 5 in it. Almost like in school we did algebra, right? Where we'd say x, where we'd say x means 5, y means 7, and x plus y then means 5 plus 7, and you calculate that. It's exactly the same thing. And here we get to choose our own kind of variables. So we save 5 and 7 in two variables called first number, second number. And these variables can be anything that we want. I could also change it to make it like Anuj's number, or second number, whatever. And then we write another line of code that says sum equal to first number plus second number. Here, what we are doing now, we are creating a third variable. And in that variable, we are saving the sum of the first two. And then finally, we are telling the computer, please print the output of this third variable that we've created. So when we run this cell, and we click here, it says the sum of these numbers is 12, right? So just take a moment to run this cell and see if you get the same output. And just give me a thumbs up. Okay, great. Now we build a little more complexity on this very basic stuff. So far, what have we learned? The computer uses a certain syntax and vocabulary to understand what we wanted to do. And based on that, it gives us outputs. So far, we've seen that we can ask it to print stuff, and we can also perform basic mathematical functions. We can do basic algebra, like I just did. We can create variables. We can save values in it and perform functions in it, and then print or display that. Now let's try and understand what are libraries and functions in Python. Now, basically, the idea is that here I wrote this code, right? This was pretty simple to write, but lots of things are a lot more complicated. And if everyone started to write all code from scratch, it would get very complicated. So, what we do is that people who code in Python, they write code, they save it, and they make it accessible to people across the world. And a saved collection of code that performs a particular function is called a function, right? So that we don't need to recycle things again and again. We just need to remember the syntax and vocabulary used for that function. So let me show you an example. In this cell now, let's see what's happening here. In the first sentence, we've created a variable which we are calling text, and we are saving a sentence inside it. What is this sentence? I am a human being trying to learn text mining. And then in the second line, we are creating another variable, which we are calling count. And here we are using a specific Python function called len, which is short form for length. What does length do? As you might intuitively think, it simply counts the number of characters that are there for whatever variable you are asking it to count. So here it will count the number of characters that are there in the sentence. I am a human being trying to learn text mining, and then it will print that out. So if you try to run this cell now, you will get an output that says the total number of characters in my text is 46, right? So we don't know what the specific code for length was. Somebody else has probably created that code, and we don't need to know that. We just need to know how to use this function called length. And using this, we can calculate the total length of any sentence. All of this might be seeming pretty basic to most of you, like what's the point of calculating the number of characters and things like that, but just please be patient. You'll see how all of these simple functions can be combined into creating really magnificent analysis as we go later on. So what I want you to do is to now try to write a code yourself. You'll see a blue bar which says now you try, and try to follow the instructions there. Essentially replace, input your text here with any sentence that you like, write that sentence and run that cell, and then run the next one and see what is the total character length of the sentence that you just wrote. And just type in the chat or put a thumbs up once you've done this and tell us how many characters are there in your sentence. And if you have any doubts so far, please ask now. Let's take a little 2-minute kind of pulse check.
Mine actually says that my text is not defined.
Okay, great. Excellent. So you got a little error. How we solve for that? Yeah. Can you repeat the error that you got, Uta?
The error message is name. My text is not defined.
Awesome. So what that means is that the computer is saying, hey, you've asked me to count something, but I don't know what my text is, which means that you probably forgot to run the first cell, which was the cell just before this. So here, when it says my text equal to blah, 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 what you have to do is also click on this cell and click on run. And then you have to click the next cell, and then you will see the output appear. So please try doing this and let me know if it works.
Indeed, that's it. Thank you.
Woo! Great. This is what computer coders do all day long. They figure out what's an error in somebody else's code and they try and fix it, and voila, get paid $1 million for doing this kind of stuff. Okay, others, were you able to do this? Anybody facing any errors? How many characters? Okay, please correct me if I'm wrong, if I'm mispronouncing your name, but May says that I just found out that they can use a different language than English in the text, which is awesome. I actually didn't know that. That's so cool. Can you tell us what language you used?
Yes, I typed Mandarin, like Chinese characters,
Wow.
and then
Cool.
it shows like the count. It's 7, so I think it works, which is great. Thank you.
Amazing. That means that whoever created the function for length or len must have coded English as well as Mandarin into Python and maybe a bunch of other languages too, which is the beauty that somebody else spent a lot of time create this beautiful function and we can now use it. It's kind of like how academic writing works, how we cite other people's work. So we can simply use other people's codes and cite it and then kind of play around with it. Others, were you able to find out the length of your sentences? Anybody running into any problems? Can you just give a thumbs up or type out the number of characters in your sentence? Okay, great. If at any point it's confusing or difficult, just stop me right there, right? Okay, thank you. Let's carry on then. So we understand what a function is. So like this, there are thousands and kind of millions and billions of functions that people have created for different domains, and they club these functions together based on kind of what domain they can be used in. And that is called a library. A library is a collection of functions that perform similar roles. So if a function is like a chapter, think of library as a book. So there will be different libraries for different disciplines. Let's say people who are working with textual data might use a library like NLTK. We will just come to what that is. Whereas people working with astrophysics will have different libraries of functions that they will find useful and so on and so forth. So lots of such libraries and their internal functions exist in the world. And based on the kind of research that we want to do, we have to become more familiar with that particular library and its functions. For example, Alex, who's present here, was talking about she wants to do research on Twitter, where she wants to download specific tweets which talk about the Black Lives Matter movement. So she'll need to figure out, and this you can do just by Googling, right? What are good Python libraries that help with Twitter data sets? And then she'll find out that, okay, there's a library called Tweepy and a bunch of others, and then she can learn those functions. So the library that we'll be using today is something called NLTK, or Natural Language Toolkit, which was created by a bunch of amazing folks. I have linked that information out. You can check it out if you'd like later on. But it's basically a library of functions that's used for textual data sets. So all you have to do is click on this cell and it will download this library for you. And it might take a few seconds. You'll see this kind of a pink box come up. So just let it happen and let it download everything. And it's really important that you download it on your kind of computer also, because none of the functions that will come later on will work unless you download it. So please download this now and wait till you see this text "done downloading collection book" appear. And again, sorry, but please give me a thumbs up once you're done so I know if it's on your system.
Sorry, what do I click on to download it? I'm not getting anything that allows me to download it.
Okay, great. So you don't need to download anything per se. It will download it itself. You just click on this cell which says import NLTK and NLTK.download book, and you simply run it by using the run button at the top. Thank you. Georgine, why don't you go ahead and run it and just let me know if it works, or we can figure other things out. Yanshin, go ahead. Do you have a doubt?
Yeah, like how do we define the variable of book by ourselves if we kind of assuming that we want to download a set of book by our choice, and how do we define that variable?
That's a great question. So what NLTK does is that it already has certain books or corpora inside it, which we can download. And by clicking book, we are downloading a specific set of books, 10 books, which we will be using today. However, it will depend on what research you're doing. You'll have to find data sets that are specific to that, and they might not be inside NLTK. You might have to go to a different website to download them. For example, a cool website that I know about is called Kaggle. Kaggle.com, Kaggle, and I'm just showing it on your screen. So I'm very interested in research on emotions. So I typed on Kaggle happiness and it told me that there's a data set called World Happiness Report. And it's an Excel file. I could simply download it. And then there's a Python function using which I can read this Excel file into my Python code, which I can tell you later on, Yanchin, if it makes sense. But basically, you'll need to figure out what specific text you need and either have those files already stored on your computer or find a website which kind of store them. And then there will be specific Python functions using which you can upload them into your Python notebook. Does that make sense?
Yeah, that makes sense. Okay.
Great, thank you. Okay, so let's move on. So in NLTK, we have two kinds of things. One is that we have corpora. A corpus is simply a collection of texts, and corpora is plural for corpus. So the NLTK library, apart from containing amazing text mining functions like the length function that we saw, and we'll see some other cool functions now, it also contains corpora or specific texts that are already present in it, which we can play around with. So just like we downloaded from the cell above, can you please click on this cell and run it? This cell which says from nltk.book import star. And when you run it, 10 texts should start to download on your browser. And you can see which these texts are in the output that appears next to it. So please do it now. And you'll see that text 1 is the famous American novel, Moby Dick. Text 2 is Sense and Sensibility, a famous British novel. Text 3 is the Book of Genesis from the Bible. Text 4 is something called the Inaugural Address Corpus, which is essentially a collection of speeches made by American presidents for their inaugural ceremonies. Text 5 is called the Chat Corpus, which is a mixture of kind of texts collected randomly from the internet, wherever people were chatting. Text 6 is Monty Python and the Holy Grail. Text 7 is a collection of articles from a business magazine called the Wall Street Journal. Text 8 is Personals Corpus, which I think, if I'm not wrong, it's a collection of personal advertisements in newspapers. And finally, text 9 is another novel called The Man Who Was Thursday. So has everybody downloaded these 10 texts? Are they there? Okay, cool. Now the fun stuff starts. Enough boring stuff. We'll get to see cool things that we can do using NLTK functions. We just need to know the word or the vocabulary of a function and how it is used, and then we can simply type it out. So the first function that I want to talk about is something called a concordance. It's a term that is used in corpus linguistics, or it's used in archival research a lot. Let's see what this does. So I've written the code here. It says text1.concordance, and in the bracket, it says God. Let's see what appears, and then I'll explain what this function does. Once you click it, you see some interesting sentences appear here. Could anyone take a guess as to what this is? Can you try and make sense of the output? Like what is the computer trying to show us here based on the command that we gave it?
Like all the sentence that contains the word of God.
Yes, exactly. But all the sentences that contain the word God within text 1. What was text 1 for us? Text 1 was the American novel Moby Dick by Herman Melville. So we are seeing all these sentences that contain God in Moby Dick. If we change the text here, let's say we make it text 3, then we see all the sentences that contain God, not in text 1, but text 3, and text 3 is Book of Genesis. So we are seeing the word as it appears in the Bible. Okay. So try running this cell on your computer and type any text name and then see what appears. And in the chat, a little activity that I'd like everyone to do in the chat, can you just type out one sentence containing God that has appeared on your screen? which you find to be interesting. Hello, U9. Thank God you were singing in text 5. Interesting. Shown the face of my deliverer God, my song forever shall record. Nice. Others, please try and type in the chat just one sentence, or if you are not clear what's going on, if you're struggling with your notebook, please let me know and I'll help troubleshoot it for you. Lamise writes, human life can escape the laws of God and nature. Heather writes that sea beast Leviathan, which God of all his works created hugest. Amelia, text 3, and God said, let there be light, and there be light, and there was light. Lishi, I heard it from the servant, God be praised, but is it true? Text 2. Excellent, cool. So this is the very basic kind of idea of text mining, that we have a huge corpus of text and we use different functions to investigate what's going on in that text based on words or concepts that interest us, right? So this is the end of the very first kind of basic setup that you needed to know, how Python works, how to use a Jupyter notebook. There's code already written. You simply click on it and it runs. And Python consists of many libraries, many functions, which have been created by coders for specific domains or disciplines. And we are using one specific library called the NLTK library, or the Natural Language Toolkit, which contains two kinds of things. It contains a lot of corpora or texts that are already there, and it contains certain functions like concordance functions, like length functions, and other functions that we'll talk about, using which we can explore our textual data sets. Lee, go on. Did you have a question?
Oh, hi, Anuj. So when we run the code, so for example, when we just saw the result of text 1, and then in the result it says displaying 25 of the 152 matches. So I was wondering if there are too many sentences, is there a way to see the rest of them?
Excellent question, Lee. Let me show you how to do that. The cool thing about Python is that for every question that you have, there's an online thread that will explain how to do it. And I had the same question, Lee, and I figured it out through a thread, but I'll just show you. So you click on, oops, not here. You click on, yeah, text3.concordance God. So Lee's question is, it's displaying 25 sentences out of 231. What if we want to see others? What if we want to see all the sentences that are there? How do we do that? What we do simply is that we type a comma next to God and we write a number, let's say any number, 45. What this number tells the computer is that these are the number of words in a sentence that we want to see around the word God. And we type another comma and we write another number. This second number will be the number of sentences that we want to see. So let's say if instead of 25, I type 50 here and I hit go. Now we are seeing 50 sentences. Oh, sorry, we're seeing 50 sentences, and what's happened is that this 45 is not the number of words, but this is the number of characters in a sentence. So if I reduce it further to 5, we'll see very less number of characters in a sentence, and then we'll see 50 sentences come up. Whereas if we write a greater number, we'll see full sentences, but still 50, and we can keep changing this to show us more and more sentences. Georgine, go on.
Maybe you're going to cover this later, but is there a way then to go to the text and see these sentences in the text? If you're going to cover that later, great, we can wait.
That's a great question. Actually, it's not part of today's workshop, but I'm sure that there's going to be a way to do it. What we could do then, let's say, And this is cool about coding. Like you have to think in the moment. I haven't thought about it, but maybe a makeshift solution that I can create out of the sentences that you see on the screen. Georgine, can you choose any one that might interest you? Maybe this one, and God saw the light.
Yeah, sure.
Yeah. Okay. So we know that this is 1, 2, 3, 4. This is the fourth sentence out of the 231 that we are seeing. So what I'll do here is that I'll write 4. We want to see 4. And I'll simply increase the number of characters that I want to see. So instead of 60, I'll write 100. And here now what we see is that the sentence has become bigger and the fourth sentence is what we were interested in. And I'll now keep on increasing this character count to see more and more of that fourth sentence. We're getting more and more context, and we'll try and make it, let's say 300. So I'm seeing a full sentence that's appeared, a full paragraph. I'll keep on going like this. This is obviously not the most elegant of solutions, Georgine, but it's a makeshift solution based on like thinking in the moment. But if I search on the internet, I'm sure we'll be able to find a way in which we can actually see the whole text pop up. Does that help? Okay, thank you. Anybody else? Any other doubts or queries at this stage? Anything that you find interesting you'd like to know more about? No? Okay, we can go forward. Yeah, so now that we know the basics, we can now start to explore specific text mining functions that will help you do some interesting analysis. The first function that I want to talk about is frequencies. What are frequencies? Counting the frequency of words in a text or corpus is the most basic text mining function that can be performed. High frequency words are valuable because they have a aboutness. They kind of suggest what the overall textual object is about. The frequency of words is a relatively objective means of uncovering some kind of importance that a text has, right? So for frequency, we have a cool function called count, just like we had the concordance function earlier. And its syntax is also pretty simple. We write the text in which we want to count the frequency of the word we are interested in. And then we write the word count, and then we put in brackets and double quotes that word. So when I do this, I know that the word God appears 132 times in text 1. So now you try, please, in the box below, try to write code that helps us figure out how many times the word God appears in the book of Genesis. And remember that the book of Genesis is called text 3. So please try and do this on your screens and type in the chat whatever is the total count for the word God in Genesis or text 3. Yes, it's 231. Awesome. Imagine if you had to do this manually, how long this would take. But yes, great. I'm glad that you're all figuring out how to use this code. Anybody who got an error or anybody who's not sure what's going on? Heather makes a very interesting point that if you don't use the capital G, then you get 0 hits. So it's an excellent point that in textual data, it's very important to keep in mind the capitalizations, the specific punctuation, the specific spellings. Like, for example, let's say hypothetically, we were looking at text that spelled God in a different way. I don't know if it's true, but let's say hypothetically in medieval English, God was spelled as Gode, or let's say if we were looking at internet lingo where God might be spelled as Gawd, God. Some people say it like that, right? So you need to use the specific spelling to get the kind of result you're looking for. Thanks for that point, Heather. Okay, so we have a count of how many times God appears in the Bible. Now, next, what you'll see is that I've created code and you simply need to run it, which will save the count of God in all these texts. If you look at this code, what am I doing here? I'm saying that please create a variable called A, and in that variable, save the count of the word God in text 1. Similarly, save the count of text to God in variable B. And we're not asking the computer to print all of this right now. We're simply asking it to save it. So please try and save it on your systems and then click the next cell also so that the count of God in all these texts appears right in front of you. Heather asks another cool question. What if we wanted to get multiple versions, God, God, and God? So for that, let's try and do something. Let's see if we can type multiple words to see that. We're getting a syntax error because this function takes only one word. So what we do for that, Heather, I believe, is that we'll simply type out all these things separately. We'd say God. And then the interesting thing about Python is that it doesn't follow all the statements in one go. So you'd have to do this here. And in the next cell, you'd then type the other spelling, and then you can simply add them up. Does that make sense? Okay. So yes, please run this cell so you have the frequency distributions of the word God in all the texts. Could you give me a thumbs up to let me know if we have the results of the number of times God appears in all these 10 texts, 9 texts? Okay, great. Now, let's try and create a little graph that visualizes this. If you go down, I'm now asking you to install another library which helps us to make graphs. And again, no need to get bogged down by what the names of these libraries are, what that code means. Simply run it. So click on this cell and click on this play button. You'll see a star here, and then you should see a number. That means it's downloaded. And then click on the next cell and run that. And you should hopefully see a wonderful bar graph like this appear. Just give me a thumbs up in the chat if this bar graph has appeared for you. Awesome. So some people are starting to get it. What does this bar graph show us? It's simply telling us on the x-axis, you have the name of the text, and on the y-axis, you have the number of times the word God appears in this text. Pretty cool, right? So what I want you to do now is just spend a couple of minutes looking at this graph and try and think of what kind of inferences or insights can we draw from this graph. What kind of claims can we make about the text that we have, the text that we are comparing, based on the information that this graph shows us? And please just raise your hand. And any thoughts? Again, there are no right answers because this is really exploratory data kind of exploration that we are doing. So there's no right or wrong answer. We're just trying to find patterns in the data. We are seeing that there are these different texts, different corpora, and the word God appears different number of times in all these texts. What kind of claims or inferences could we draw based on just this graph? And some hints, there are many ones. So try and think about how we can differentiate between these texts in a corpus. What happens when we differentiate these texts based on their genre? What kind of insights can we draw there? What happens when we compare them based on their years of publication or their cultural contexts? Take really wild guesses here, wild kind of claims. Nobody's going to be reviewer too and criticize us for the lack of evidence in our claims. But just take a shot. Anything that comes to mind.
Well, I'll just comment that it's interesting how much Moby Dick uses the word God in relation to the book of Genesis. It's close, sort of close.
Interesting. Excellent. So Jojean's made a wonderful point that Moby Dick and the book of Genesis use God quite a lot. What would that tell us, Jojean, about the cultures that they come out of? or their genres or anything else about, since we do know a little bit about the context in which these two texts were written?
Well, you could make the argument that the presence of God is a significant theme in Moby Dick, especially compared to the book of Genesis.
Excellent. Yeah. And that might want us to explore the role of religion in Herman Melville's writing. It might want us to explore the role of religion in that particular historical era. It might want us to do a whole lot of things. Uta, did you have something to add? A new kind of insight?
Well, I was thinking that I guess these personal texts are like modern day texts. And so
Yes.
that's telling to me as an early modern historian, because I would venture that early modern personal texts would have the word God almost as often as Moby Dick and Genesis. So it really speaks to, thinking about the period that you're looking at.
Exactly. So this personal corpus, Uta, as I said, I think they are not early modern texts. They're, I think, pretty like contemporary, 20th century, 21st century, and they're from advertisements in newspapers. So what I got from this data, as you said, is that the period is really important. And while God is a very important kind of discursive concept in the Bible and in certain literary texts, even in the early modern era, in the modern commercial space, God really has not much of a role to play. People don't really use the word God to sell products. So I would say that the commercial sphere is kind of bereft of the idea of God, at least within this culture, this kind of context. But thank you. That's really interesting. Anybody else? Any other insights that you'd like to share? And if you're not comfortable speaking, you could also please type in the chat. Heather says, I wonder if there's something to say about genre too. Yes, exactly. Chat and personal, really different than Genesis and inaugural speeches. Yeah. So we could also make the claim that historical comparison is one thing, but also certain genres use the concept of God a lot more, certain genres use less. Personal correspondence in the modern times uses less of that. More formal genres like president speeches do it a lot more. Then Aziz says it's surprising to see the word God so infrequent in chat, given how frequently it is used in daily communication. But I checked OMG in the chat corpus and got 29 uses. So perhaps it's about capturing as many interrelated variants as possible. That's so cool, Aziz. Excellent. So for those of you who are interested, maybe you can explore other variations of the word God, as Heather had pointed to us earlier. And Aziz found out that when you use the abbreviation OMG, which means oh my God, you see a lot more of that in the chat corpus. So then we'd get to refine our earlier claim that it's not that God is absent from the chat corpus or modern personal communication. It's that the discursive framing of God has changed over time, right? All of these, obviously, like these are very tentative claims, right? Our corpora are very limited. We are making sweeping generalizations here, but this is just to give you a sense of how you could use these simple techniques and make them a lot more rigorous in your own research. Anybody else? Would you like to make any further claims? Alex says she'd be curious to see if all the presidents included in the inaugural addresses use the word God to appeal to their constituents' spiritual sensibilities, or if it's more so just a customary practice. Excellent idea, Alex. And this is where we can combine multiple techniques. Using this, we found out that, okay, God appears, here's a certain frequency. Now you could then use the concordance function that I spoke about earlier and look at the specific ways in which presidents have used the word God in the presidential corpus and try and find an answer to the question that you're interested in. Super cool. Anybody else? Any other insights? Okay, I think we'll take a little break here. It's, what time is it? It's 3:54. So let's be back at 4:05 p.m. and then we can continue. We are done with half the workshop. Now we'll try and learn a couple of more cool techniques like this. And we'll also start exploring not just the notebook, but for each technique that I'm telling you, I'd like to introduce some interesting studies that have used that. And we'll start off the workshop in the next half by looking at how a historian used frequency counts to look at the Black Lives Movement on Twitter. So yeah, we'll start with that at 4 or 5 p.m. See you in a bit. Bye-bye. Hi, everyone. We'll start in just another minute. Before we begin, though, so there's a quirky thing that happens with Jupyter notebooks that if you leave it inactive for a while, it kind of starts to glitch. So we'll have to reload it. So can you just click on the link that Jeff has shared in the chat again? And it'll take another couple of minutes to reload, and then we'll begin from where we left. And don't just refresh the earlier link that you had because that won't work. You'll have to click on the link again. So just click on what Jeff has shared in the chat. Okay, as this notebook is loading in the background, I'd just like to start with a little discussion based on the very little technique that we've learned so far, just frequency counting and concordances. How do you think you might be able to apply that to something that you are researching? Any kind of projects that you have? How do you think these two techniques might apply to your data? Alex, please share with us. Thank you.
Hi, this is Alex speaking. So I am doing data scraping. For those of you who weren't here at the beginning, I'm doing data scraping of social media spaces, specifically Twitter, looking at tweets related to the Black Lives Matter movement and any subsequent hashtags that have come out of it, like Black Girl Magic, Black Boy Joy, Black Excellence. And so this has been super informative because it allows me to sort of think about very intentionally and carefully about the kinds of words that I'll be looking for in terms of the frequency that are used along with the hashtags to sort of see how people are using these hashtags either positively, negatively, neutrally, and then what other kinds of contextual information sort of surround those hashtags. Are there images associated with it? Are there like personal narratives associated with it? Are there other sort of hashtags that are associated with those hashtags? So this has all been really, really great in terms of thinking about contextualizing how these hashtags sort of fit into that larger conversation.
Amazing. Thank you, Alex. I'm so glad you found this useful. The magic is just getting started. Wait till we look at other techniques. I mean, and everything that we do in this workshop, it's like the kindergarten of text mining. So if you find this useful, the moment you actually start learning text mining through courses or through other online resources, you'll find a lot of value in your research. Thank you. Jojin also says that if we can look at every time an author uses a word in their entire oeuvre, you may have a clear understanding of the meaning. Exactly. So for example, Margaret Atwood uses made up words in a science fiction. Very cool. Yeah, you could explore that. And this technique really works well in comparison. So if let's say you wanted to see how the idea of, I don't know, I haven't read Atwood, so I can't make a word. Say hypothetically, you want to see how the word science has been used differently by Atwood in two different texts. That would be an interesting thing to explore, or just compare it across texts. So lots of fun things are possible. I just want to show you now very quickly two studies that I've found to be very cool, that I've used these techniques to do really amazing analysis. And could you just give me a thumbs up if your Jupyter notebook has loaded again? If for those of you who are just joining, basically Jupyter Notebook starts to crash after you leave it inactive. So please click on it again so that it can load. Okay, most people seem to have loaded it. So I'll share my screen again. And if you scroll down, down, down under raw frequencies, let's ignore this whole section of normalized frequencies. It's helpful, but I think given the time, I'd rather skip over to other things, but we can come back to it later if we have time. I want you to look at, oh yeah, let's do this. Yeah, let's look at this study right here. what this researcher did was that they did what Alex wants to do. They did something called Twitter scraping, and scraping is a cool word basically for extracting data from the web. And what they did was that they downloaded all the tweets from different big American corporation companies, and they created this graph based on that. And what they did was that they are showing us each time a company uses the hashtag Black Lives Matter, and we can see when it does not. So in this graph, what you can see is Walmart, and Walmart tweeted twice on May 24, once on May 31, so on and so forth. You can click on the dot and the specific tweet appears. And whenever the tweet is light gray, that means it's not a Black Lives Matter tweet. Whereas if it's black, then it has some connection to Black Lives Matter. Using this really cool tool, they did it for Amazon, for ExxonMobil. And then here, what you start to see is that you can see which companies are simply not interested or supportive of Black Lives Matter. And then the author and their group kind of try to advocate and try to pressure those companies to give a statement about why they don't care about the BLM movement. And then you could also create advocacy and activism about wanting kind of nudging people to support or not support certain brands based on like kind of the protest movement that you're trying to organize. So you can see that while some companies like AT&T are very frequent and they're mentioning of Black Lives Matter, some companies mention it, but they do so on specific days, which are more significant. Whereas some companies like Ford simply do not mention it at all. So this was quite an interesting use of a simple technique of frequency counting that I found useful. Any thoughts or questions on this study? You could type in the chat or raise your hand. And then the next study that I found really cool is this one, which I'd like to show you. Oops. Yes. In this study, what the author does is that I hate it when you have to log into this again. Just give me a second. Yeah, so this paper is called The Rise and Fall of Biodiversity in Literature. And what they did was that they created a huge dictionary of words that refer to anything that has something to do with biodiversity. So names of animals, names of plants, anything like that. And they took a huge corpus of Western literature in the 20th century, 19th, 20th century, I think. And all of this is complicated. We don't need to get into the nitty-gritties, but essentially what their insight was that, let's try and open this graph if you can see it. Yeah, so what you see here is that they found that various parameters of biodiversity up until the year 1835, 1836, 1837, those mentions of terms that relate to biodiversity were increasing in Western literature. However, after 1835 and so on and so forth, in contemporary times, we see a reduction in the number of times biodiversity is mentioned by authors in the Western canon, based on which the claim that they're trying to make is that growingly, Western literature is becoming more and more alienated from the biodiversity around them, from nature around them, whereas earlier correct me if my literary periodization is still correct, but during the Romantic era, there was a lot more connection between Western authors and nature. So you see a rise there, but then later on, you start to see a kind of decline. So there are lots of these interesting ways in which researchers use just absolutely basic things like counting the number of times a word appears in a text. Cool. So let's get back to the Jupyter notebook. And just like you needed to reload the notebook because there was a little bit of inactivity, we'll need to re-click on some of the cells, especially the ones which had downloaded the libraries for us. So can you bring your cursor back up to the first cell where we had import NLTK written and run that so that the NLTK library downloads again for you. Once that is done, then click on the next one, which says basically keep clicking on each cell from the first NLTK one, not before that, just from the NLTK one to everything that we've already done. Click especially on the one that says count. Basically, let's recreate the bar graph that we had and stop here. So once you have this bar graph again in front of your screen, just give me a thumbs up. Great, Yanchin has a bar graph. Others also please do it. And if you're running into any errors, let me know.
I do have kind of the server connection error all the time, like 2 minutes.
Sorry,
Every
Yanchin,
yeah.
what's the error?
Yeah, for every 2 minutes, there's a window called server connection error jump out and ask me to dismiss it.
Yeah, so you can dismiss it. What I think might be happening is that you need to reload the Jupyter notebook. So
Okay.
can you click on the link that Jeff has shared in the chat? And I'm
Okay.
sharing it again.
Great.
And then let the notebook start again. That's what I was saying, that sometimes these notebooks crash if you leave them inactive. So you need to redo it. Okay, great. So looks like many people have the graph. So we'll move ahead slowly. We're leaving out this chunk on normalized frequencies because of lack of time. But later on, if you have time, I'd appreciate if you come back to it. Now I want to come to the section called dispersion plots 2.1.3. Right now, what we did was we visualized the total number of times a word appears in a text, right? So it's like a whole text and the number of times. But what dispersion plots do is that they show us how a word varies within a text. Let me show you how. Text 4 is the American presidential inaugural corpus. And when we run it, this is the dispersion plot that comes. On the x-axis, what you see is, think of it almost like the chapter numbers in that corpus. What is that corpus? That is the corpus of the speeches of American presidents over time. So 0 chapter would be perhaps one of the first speeches. I don't know, I'm not too familiar with American political history, but maybe Lincoln or like George Washington, one of those guys might be in the beginning. And then towards the end, towards the 16,000 mark, you might have people like Obama or people like Trump. Their speeches might be here. So that's the x-axis. It's the speeches flowing through time. And on the y-axis, you are seeing certain words. So when you look at this graph, if it's a lot of blue lines appearing together, it means that this word is being used more frequently at that marker of the text. Whereas if you see a lot of white spaces, it means it isn't used there. So for example, you can see that the word democracy was not used very frequently in this corpus at the beginning. However, towards the end, you are starting to see the word democracy being used a lot more, right? So 2 questions for you all. 1, does this graph make sense to you? If not, like, please tell, we can discuss it. And 2, what kind of inferences do you think we can draw about American presidential culture based on this graph? Yes, Uta, would you like to share something?
Yeah, I would be interested to know whether other terminology for God was used in earlier inaugural speeches, so that maybe God is not the only word to search for, as we already discussed. And I would also be interesting to see how republic relates to democracy. So I think that for me, the point is that to really be confident about this, I would probably run a lot more terms to get a
Wonderful.
better sense of what that actually means.
That's a great thought. Uta, do you want to run some of this? All you'd have to do is replace a word here, anything that is not useful for your research, and type that out. So maybe let's say instead of citizens, what did you say? Republic, right? Let's try
Yeah.
and run that. Oh, interesting. Republic is even less than this. Maybe let's try a capital spelling of republic. Maybe that is more frequent. Yeah, so republic appears as the capital R a lot more. And it's appearing a lot more consistently than democracy. I don't know what kind of insights you could draw based on that. Similarly, for God, if you have any spellings of God which are more aligned to 17th, 18th centuries, maybe we could try that. But yeah, do some hit and trial and let's see what happens. Let's see in the chat. Um, Heather says democracy is a modern construct. That's very interesting. That's an excellent hypothesis. And this is the cool thing about data mining or text mining, right? Based on what the data shows us, we create a hypothesis and then we try and go deeper into the text to try and understand it. Jojin says bad news for duty. Yeah, that's something that I was also thinking, that while the reference to freedom is increasing over time, everybody wants freedom, the reference to duties is increasing. So a hypothesis could be that it's more persuasive to talk about individual freedoms, whereas not so much to talk about the duties that the public has towards the whatever republic. And Alex says that the concept of citizen or citizenship has been a constant concern or point of contention for all of US political history. That's so insightful. Yeah. If you look at the graph, um, okay, I don't have citizenship right now, but maybe at later, let's put citizen and then see what comes up. Yeah, citizen is here. Oops. Citizens are perhaps the most frequent. So we are seeing that, yeah, it's really important for American political discourse. So it's actually a corpus that is huge, has like all the text so far. And using this simple technique, we can find interesting discursive patterns which can guide our future research. Jojin says duties have diminished while freedom responsibilities increase. Exactly. Yeah, that's another interesting point. And Jojin has shared a screenshot with us. Let's try and see. Yeah, so Jojin has used the words inflation, oil, economy, prices. Um, and economy is more frequent, prices is also there, and oil interestingly has no place, which is very, very interesting to me. Maybe it has something to do with the fact that inaugural speeches are not the space where American presidents talk about oil, but other speeches are more relevant. So yeah, just take a moment to explore any word that seems interesting to you in this particular corpus and see what kind of interesting insights you can gather. No worries, Heather. Thank you for joining us. Bye-bye.
Oh, I
Uta,
just
yeah.
read energy, and that gives us quite a bit of results.
Oh, cool. Energy. Nice. Let's see. Energy. Oil. Oh, sorry, I spelled energy wrong. Yes, energy does have a lot of things. What else could be interesting? Megan says would be interesting to get a State of the Union corpus and compare terms used in inaugural address and State of the Union. Yeah, that would be fascinating. Cool. So yeah, this is another cool trick using which we can explore our text. Now, the presidential corpus obviously makes for a good use of this because it's arranged according to time. But let's say if you were using a novel, then also it could be interesting how a writer's conception of a particular concept or character has changed over time. For historians who are looking at historical archives, obviously it's very interesting to see how these things evolve. So lots of fun things that we can do with this. We'll move on to now. One final technique. No, how much time do we have? Okay, we can do two techniques maybe. So concordance is something that we've looked at earlier, right? We've seen how we can see the specific context in which a word appears within a text, and we did that to God. We saw in text one, we had these sentences for God. So can you all now try it yourself and display the concordance lines that contain the word God in any text of your choice from the corpus? So either text one, text two, till up till nine, anything. Use this code here and adapt it so that you see concordance lines for the word God in any text apart from text one. And just give me a thumbs up once you're done. Great. The try is done. Others, if you're getting any errors, please let me know. Alex also has some concordance lines. Alex, can you tell me which text you chose?
I chose the man who was Thursday.
Okay, so that's text 9. Dot concordance. Interesting. Others, can you tell us what text you chose? Anybody? Just want to check whether you've been able to do this or whether there are some kind of errors that are coming up. Okay, Jojine has done Wall Street Journal and found that it has no mentions of God. That's actually not surprising that the commercial world doesn't really care about God in the modern times. It doesn't really help them make any more money. So yeah, quite insightful. So the next thing that we should do is now let's try and do some more granular analysis. We saw earlier that we can compare the frequency counts of the word God across two texts and try and make some assumptions that, okay, it matters a lot more to Moby Dick than it matters to the Wall Street Journal. Now, choose any text that have a lot of mentions of God, and let's try and analyze the specific ways in which God has been used in those texts, and let's try and derive some inferences about that. So next is, what kind of inference or hypothesis can we draw by comparing the concordance lines within text one? Which was the text one? Text one is Moby Dick. And within text 9 or any other text that you've chosen, you can choose the Bible, you can choose any of the novels or anything like that. And let's try and make some claims about that. You could look at, you could focus on the kind of grammatical categories in which God is present. Has it been used as a proper noun or a common noun? What kind of tone do the sentences have? Is it formal? Is it reverential? All kinds of kind of syntactical contextual analysis. And let's try and come up with some hypotheses or claims based on that. And we're all humanists and social scientists here. Our bread and butter is close reading. So this is it. This is our moment to shine.
Can you explain again how one sees more of the text?
Yes.
Thank you.
Great question, Uta. So Uta says, how do we see more of the text? In this code, after the word God, you add a comma, and the next number that you enter is the number of characters that you want to see in each sentence. So you could make that into 100, for example. And right now it's showing 25 such sentences. If you want to see more, you could increase that in the next number and simply run the code again. So here you'll see 30 sentences and the length of the sentence or the context line has increased. You can keep increasing that middle number to make it even bigger. Yeah.
Thank you.
Awesome. Okay, let's take the next 3-4 minutes to do this analysis and find out some interesting insights about a qualitative difference, not a quantitative one, between the use of God in two texts.
Is it okay to say something?
Yeah, please go ahead, Uta.
Well, I just did Jane Austen because, and I noticed that the results I'm getting are actually like all exclamations, basically.
Interesting.
So
Can
it's
you
not,
tell us what's the number of the text for Jane Austen? Is it text 5 or?
that's number 2.
Okay, great. Let's do that then. Yeah, please go ahead.
And she has only 10, and they're all, I mean, I only see
Oh.
exclamations like "Good God, gracious God, thank you, thank God." So my God. Well, the last one is not, but I think there are 2 that may not be, but it's very striking that they're basically exclamations
Yeah,
where people are using them in kind of everyday language.
very interesting. And how do you think this compares to, let's say, a biblical use of the word God?
Well, clearly, as we looked at earlier, it's actually about God. So, I mean, it's basically a completely different thing, if you will. There's
Yeah, I
yeah,
also noticed that excellent insight, by the way, that God has become a figure of speech in Jane Austen. It's almost used as only an exclamation. So we're not really talking about uh, God as an entity. It's literally just a figure of speech. And I don't know, from a historical standpoint, that's so interesting. Jojine says that she was typing the same idea that she's noting. Yeah, it's very insightful. Others, anything else that you noticed by comparing between two texts? Any qualitative insights? Alex, Alex has something interesting for us. In the first 25-ish results for both the book of Genesis and the man who was Thursday, the figure of God feels like it's described as more concerned with vengeance and righteousness. There are other descriptors about his quick wrath and making a hell for those who disobey him. Okay, yeah, that's very interesting. Yeah, that God is somebody who is only angry and full of vengeance. And I wonder how this would change when we look at the presidential corpus, because my guess is that American presidents aren't really presenting a very vengeful idea of God, but rather a more benevolent God who is blessing the American nation or something like that. I mean, that's an hypothesis I would have. Great, thanks, Alex. Anybody else? We can have one more inference or hypothesis and then we can move on.
I have a question.
Yeah, go ahead, Mariana.
So in this code, we are finding 2 word phrases and 3 word phrases. So why doesn't the 2 word phrases appear inside the 3 word phrases? Does that make sense?
Mariana, I think you might have skipped the notebook a little bit. Are you in the collocates analysis section, which is coming up next? The bigrams
Oh,
and
sorry. I am.
Yeah. No worries. We
Sorry,
haven't
sorry.
covered. We're coming to that just in a moment.
Okay, apologies. I'm sorry.
Okay, actually, now let's move ahead to that section. The final kind of technique that I want to introduce is something called a collocates analysis. Has anybody come across this term collocates before? Do you know what it means already? Anybody want to take a shot? What it means to them intuitively or something they might have come across before? Mariana, since you're representing Crow, would you like to take a try?
Okay, I might, but I'm not at my sharpest apparently, since I already got lost in our notebook.
No,
So
that's okay.
the idea is that we want to find, for example, here with the word God, we want to find which other terms that usually appear with this word that is statistically significant. So for example, so far we have searched for the word God, but what other word commonly appears with God? And then we would go from there to see what that means.
Excellent.
And then, yeah, if we want to extend the analysis, then we would try to understand if those groups of 2 words, 3 words, if they have a meaning in itself, or if they have some function, some discourse function in the text, things like that.
Very cool. Thank you. So collocates basically is, as Mariana beautifully explained, it's essentially the next trick where the first thing we did was we just typed God and we saw all these beautiful concordance lines. Now, obviously, if it's 231 lines, it's going to be quite difficult to read each one of them. And maybe even 230 is manageable, but let's say you were dealing with a huge corpus which had 20,000 lines that mentioned God. Obviously, it would be humanly very difficult to do that. So the next technique that corpus linguists use is something called collocates analysis. What it does is that it performs a kind of statistical analysis on all these sentences to tell us which are the words that appear next to God more frequently than others, which are the words that are really tied to the concept of God. And how they do it statistically is complicated, requires a lot of mathematics. We don't need to delve into that right now, but this code just exists. So we can play around with it and see what it does. And I've written this code here and let's just run it. I've put text 4 right now, and text 4 is the presidential corpus. So let's see what happens when we run it. Here is the output. It says that the 2 word phrases that most significantly contain God in this text are God bless, Almighty God, God, comma, under God, may God, so on and so forth. And 3 word phrases are God, full stop, we, God's and God, God bless you, God bless America, God bless, and God bless. So interestingly, what we see here is that in the presidential corpus, while God has been used many, many times, it seems like God is used again and again with the word bless. The noun God is associated significantly with the verb bless, and often then nouns like you or America, which gives us insights into how God is being discursively framed within the presidential corpus. Let's try and see what happens when we do this to another text. And now would you like to do this, please, in your notebook? And what you have to do, this code looks a little complicated, please don't worry. All you have to do is simply find wherever text 4 is written in the code. It should be in two places, here and here. Just replace that with any text that interests you. It could be Sense and Sensibility, it could be Bible, it could be anything else, and see what kind of collocates come up with that. I'll do it for text 3. Which is the Bible. You all do it for whatever you find interesting. And again, the process will be the same. Let's try and compare and draw some inferences across what we found. This is a little complicated because the code is a lot to read. So please just tell me if you're facing any errors. You don't need to read the code at all. Just find wherever text and a number is written in it and just change that to a text of your choice. That's all. And then run it. Okay, would somebody like to share what they found? Any inferences they see between the differences in the collocates of God in the two texts of your choice? Eugene says, confirming what Uta was noting earlier about Sense and Sensibility, the most common collocate with God was exclamation mark. Excellent. So Uta had a hypothesis earlier, an inference which appeared in the concordance line. And in order to make it more valid or provide more evidence for it, she could now do a collocates analysis, and that would give more credibility to her claim. So this is how you would write it up if you wanted to do this research. Excellent. Others, anything else that you found that seems interesting? Somebody who hasn't spoken so far, anything that you'd like to share? Or others, anything? Okay, maybe I'll share something that I found interesting. I did it for the presidential corpus, and I showed you that it came up, the common phrases were God bless America, God bless this, God bless you. So bless was the most common verb with which God was used. Whereas when I did it to the book of Genesis in the Bible, I saw a whole larger range of verbs that were used with God. So God hath, God said, God created, God saw, God had. So it kind of tells me that in the biblical imagination, God is seen as performing a whole range of actions, whereas in the presidential, American modern presidential imagination, God's function has primarily been reduced to just blessing the nation or doing something else. The discursive frame of activity in which God is operating has reduced in this text. Anything else that any of you noticed? Mariana, since you were looking at this earlier, would you like to share what you found?
Okay. I was thinking that I was thinking if the two word phrases wouldn't repeat in the third word phrases with something else. For example, God said, in the output of the two word phrases, we have it again in the three word phrases, and God said.
Yeah,
But we don't have, for example, God created.
interesting. So you're trying to see which is the unique output from these two lines, And God created is one of those things. So what does that make you think of?
I don't know. I would expect it to be in the third word output too. Like God created and then something else.
Yeah. So what we can do for that then is maybe, I don't know, I haven't tried it, but let's go back to our concordance lines and let's try and see what happens when we search for God created. And we find no matches. Interesting. That was, where is God created appearing? In text 4. Oh, sorry. Yeah, text 4. And type God created. Very strange that we have no hits for that. Maybe there's a punctuation then that's missing. Yeah, it's a two-word phrase, God and created. So what that tells us is that the words God and created don't appear immediately next to each other. There's something in between them. So let's try God hath created. Okay, no. Let's try simply create. Yeah. So now we can see it. And God created great whales. God created man. God created he, him, he, them, and made, and so on and so forth. So we're seeing a lot of created here. Yeah. So maybe you'd want to then explore these nouns that come next to God created. It would be Adam, whales, humans, so on and so forth. The word woman doesn't appear here, interestingly, does it? Oh, male and female. Okay, interesting. Thanks for pointing that out, Mariana. Ludmila asks, what statistical data can be extracted from collocates analysis? That's a very good question. I think the main data that you can extract is something called a PMI, which is the measure, which I don't know how it appears in this code. Let's try and find that out. Print big gram measures dot likelihood ratio. I'm not being able to find that right now. Ludmila, I'm sorry if I'm mispronouncing your name, but I can get back to you on that. Essentially, basically a score comes up which tells us how significant or how important that particular collocate is, and then we can rank it in that list. So the specific statistical technique that you use to calculate your collocates, which here what we've done is that I believe it's the PMI index. Yeah, it's the PMI index and likelihood ratio. So based on that, we could spit out some numbers, but I can share that with you later on. I'll have to look it up a little bit. Okay, thank you. So that's all the kind of techniques that we had. And just before we close out, there are resources at the end of this notebook about what to do when you want to do this work for your own research. First is try and play around with a lot of existing corpora or data sets. I've included links which you can click out to. You'll find lots of free data sets that you can download yourself. You can also create these on your own. For example, Project Gutenberg is something really big for literature and history scholars, which has all these ebooks which you can simply use for your analysis. You can also create your own corpora of texts using this link. You I would also recommend that you start reading journals that publish this kind of work, which would help you. And I've also listed a range of resources which I've used to teach me text mining, which in a step-by-step fashion, like almost like a book, would help you learn these things. So at your own time, at your own pace, please try and explore these resources. It will really help you. Everything today was just like a little teaser, a little taste that would kind of give you some sense of what all is possible. And given the shortage of time, we haven't been able to cover everything, but this workshop is present for you and anybody else on the internet who wants to use it. So please explore it on your own and try and see where it takes you. Before we close off, just two things. One, I wanted to get a sense of what your experience has been like, what you've learned, what you've been confused by, so we can improve this workshop. So I'm sharing a little form in the chat. Could you please take 2 minutes to fill that? That will be helpful for both me and the folks in the library to help improve our workshops. And after that is done, I'd like to just quickly talk about your experience and how you think these skills could be applied to your research. And sorry, I know I'm really mispronouncing your name. Could you tell me what's the correct pronunciation? Lyudmila, is it?
Yes, I go by Lucy.
Okay, great. So I
Lucy.
found something that might be helpful for you. I'm putting it in the chat. It basically tells us how to extract the statistical indexes based on which this score is created. And if you know coding, I think you'll be able to read it. But if you'd like, we can later on connect and I can help you use this code.
Thank you. What does BMI stand for?
Not BMI, but PMI.
PMI.
Yeah, it's something like I don't know what P is, but MI is mutuality index, which essentially means how likely are those two words mutually associated with each other. So it could be, I think, primary mutuality index, or I don't know what the P stands for. We'd have to look it up maybe.
But it's different from correlation, right? Your sense correlation. Or is it based on one of those correlation models?
It's inspired from the idea of correlation. It's like a more complicated version of correlation specifically for textual data and with a lot more reliability and credibility. Like correlations are weak, right? I mean, we're not as convinced about there being something. It's just a starting point, but collocates used almost as conclusive evidence for something.
Thank you.
Others who are done filling the form, would you like to please share how some of these techniques could be applied to your work, or any doubts that you have, anything that you'd like to explore further? I'd be happy to share about that.
Well, thank you. That was really very helpful. I think the one problem that I have is that, as you're probably aware, early modern spelling is not standardized. So any tips to deal with that?
I think, oh yes, Ken, thank you. PMI stands for Pointwise Mutual Information, Ludmila. So you could check that up later on. And Uta, that's a fantastic question. I think you might benefit from talking to other scholars who are already doing this kind of work. And here, I think some more complicated techniques like machine learning might be helpful. I don't know about in this particular context, but there are people who work with, let's say, devices like Alexa, right? So when I say, Alexa, please play Brian Adams's Summer of 69, my accent is very different from, let's say, when you might say it. But Alexa is processing that language to mean the same thing using machine learning. So it might be able to do that same thing for spelling as well, if it can do for pronunciation, maybe. So it might be interesting to explore spelling variation, machine learning, and natural language processing or text mining or something like that.
Thank you.
Go ahead, Georgie.
I could see myself definitely coming up with some research questions, some queries, but
Mhm.
I'm so new to this. I assume there are librarians that I could go to who will help me with this. Would that be like the English librarian that I work with normally? Or is there someone specific?
You, Jeff Oliver from the library.
Yeah, hi there. Yeah, so it's a good question. We have just earlier this year we were able to hire a librarian who has expertise in text and data mining, and I can give you her name. Her last name is Froelich, Froehlich, Heather Froelich. Her first name's Heather, by the way. And so Heather would be a good person to reach out to for more resources, next steps, and other sort of ways to learn more and get involved in this sort of research.
Great, thank you.
Also, Georgine, I think what really helped me was to take a few classes at the university, and I just audited them so I wouldn't be scared about kind of losing out on grades and things like that. So I can recommend some classes. I'll type it out in the chat. ISTA 130 is a great undergrad level introduction to Python. And then Info 514, which is what I'm doing right now, is a little more advanced for social sciences that has really helped me. So these two classes I would definitely recommend. And here is the textbook that is wonderful. It's the website that we use today, Jupyter Notebook. It's built kind of like that, and each chapter teaches a specific technique of text mining. It's by somebody called Melanie Walsh, and it's a freely available textbook. You can just click on the link, it'll open up, and you can do all these exercises there. So I would strongly recommend starting off with these things. Either take some of these classes or use this book, and obviously reach out to Heather. And that's the very first thing. And I learned about a lot of these resources through her. Also, I am always super excited to nerd out on any text mining things. So if you ever want to just reach out to me on my email, if I don't know, I can always find things for you. That's the beauty about the coding world, that everything you want to know is already there online. And if it's not, all you need to do is like ask about it, and there are wonderful forums where everybody answers. Like Uta, for example, if you want to find out about what you said, the spelling variations, I'm sure there are hundreds of threads online. So there is a website called Stack Overflow, which where people put their coding problems and other seniors kind of respond to that. So you could check that out. And also the journals that I mentioned, that would be helpful. And Ken says that there are several modules on text data mining on Edge Learning. I didn't know that. That's so cool. I didn't want to check that out. If anyone hasn't used Edge Learning, it's that online asynchronous learning portal for the University of Arizona where we do all sorts of trainings. So there's stuff on data mining there too, which would be super cool. Like, I really think all of us and more people like us need to get into this, because otherwise it's just tech bros who are designing technology, And I think that technology development, coding development needs to be informed by a lot more humanistic tenets, a lot more social science tenets. So, and it's not difficult. All of us can do it. I am a clear example. If I can be an advanced novice, so can all of you, and we can keep on doing it together. So, strongly encourage you. I really appreciate that you've taken out these 2 hours to come here. And also want to give a shout out to Jeff and the library and its program, Data Science and Digital Scholarship Fellowship, which has been training people like me over the last whole year to do workshops like this. And I don't know if the call is still out, Jeff, but I'd encourage you guys to apply for that. So you can get a year-long mentorship in learning these skills. And you also get a sweet little stipend to do that.
Well, thank you for that, Anuj. I don't really have anything to add. Just there was a spectacular workshop, an introduction to a complex topic, and Anuj mentioned a bunch of resources that that we would encourage you to check out. And then we've got some folks here in the library that can also help if you're ready to dive deeper into this. So thanks to everybody for coming. And if you didn't already, please take a moment to fill out that little Google form. It's really important that we have your feedback so we can gauge how to do workshops like this in the future. And then also to set up programming and opportunities that maybe we haven't thought about yet that you would like to get involved in, or you would like to see some groups like the libraries offer. We really do take your input and appreciate what you have to say. So thanks to everybody for coming. We are at the top of the hour. I think I will stick around, and Anuj might have a couple minutes to stick around if anybody has any lingering questions. And if not, then thanks, folks, for coming.
Before you close the meeting, just wanted to ask, is the call for application still out for next year's fellows?
We don't know what's happening next year yet, unfortunately. So we're not quite sure. So we haven't opened the call for applications. We're still sort of figuring out what to do with that. So thanks for that. There are some other workshops that are happening on later in this week. If folks are interested, I think the announcement that you got probably had a link to our website, and I could put that in the chat too. So thanks for asking, Anuj.
Thanks so much for coming, everyone. Really appreciate it.
I just wanted to apologize. I came in very, very late. I had another committee meeting and it was just, over schedule. Is there a way I can access the materials of today's session?
Yeah, so we'll send an email with the link to the notebook that we used as well as this recording. Later on, Jeff, it'll be uploaded on the website, or I don't know how it works.
Yeah, we're gonna figure out how to supply it. We're still sort of working out how we provide video content, but yeah, we'll have something available.